Part 2 of Learning Target 12, solving equalities instead of inequalities. We're not looking at the shading and where the graphs, the shadings overlap. We're just looking at where the equalities overlap, where the two parabolas overlap, or a parabola and a line overlaps. So there can be one answer, two answers, or no answers, depending on the pictures. All right, in example 6, I went ahead and took my calculator and typed in the first y equals and the second y. We're going to take a look at the picture, see where we think these are overlapping. Looks like they're overlapping around 0, -5, and over at x equals like -2 or 3-ish. So we're going to go to the table and see what we see. Go to the table. I'll scroll down to about right there because we can see both answers there. We thought they were crossing at 0, -5. The first y equals has the point 0, -5 in it, and the second y equals has the point 0, -5 in it. So yes, that's where they're crossing. The other one we thought was around x value -2, -3. So when we look at x value -3, you'll see y value 4 in the first y equals and y equals 4 in the second. So those are the 2 points. And by the way, we really didn't have to do that, but I did want you to see it in your own calculator. We just graphed those two in number 4 over here. And where did they overlap, or where did they cross? 0, -5, and -3, +4. So we already had that answer. I wanted you to see it in the calculator, though. So a little sketch of this, just so we have a little in our memory what happened here. Why did we get this answer? Look like that. And something like that. Our 2 answers. 0, -5, and the -3, +4. That's solving by graphing. Now again, these are all nice and pretty answers on the notes, but we need to know how to do it with substitution. So number 7, we're going to do it both ways. First, algebraically. Second, with the calculator. I probably recommend vice versa when you're doing a problem on a quiz or test. Check the calculator first, and then go to algebra if you have to. If the answer is a decimal, you don't have a choice, really. Okay? At least for now. All right, substitution for number 7 would say this. Substitution. Take your 2x squared plus x minus 5 and substitute it for y in the second equation. So 2x squared plus x minus 5 equals -x squared minus 2x minus 5. To solve a quadratic, you need it to equal 0 algebraically, because we're going to go to either completing the square or we're going to go to quadratic formula. Which one's your favorite? My favorite is quadratic formula of the 2. So that's what I'm going toward. So I like a positive x squared, so I'm going to add x squared to the left, forcing me to add or subtract everything to the left side. So I'll add the 2x to the left side. I'll add the 5 to the left side, and that will leave what on the right side? 0. On the left side, a 3x squared plus 3x, and then those 5's cancel, so a 3x squared plus a 3x. And we'll go to the quadratic formula to find our 2 different x's. I will kind of remind you, this picture is going to look something like this in your calculator. So remember that there are 2 answers that we're looking for. It does cross twice. And we're about to find 2 numbers for x. We are about to find half of each of those answers with the quadratic formula. Personally, I really would divide by 3 here to both sides and get rid of the 3's so that I'm working with an a of 1, a b of 1, and a c of 0. But you might not think to do that, so I'll just stick with the 3. Okay? Quadratic formula. Opposite of b, plus or minus some square root over 2 times a. And now we'll do the discriminant. B squared, 9, minus 4 times a times c. Doesn't matter. C is a 0, so it doesn't matter what the other gives you. You're subtracting 0 from 9, so your discriminant is 9. So you end up with -3 plus or minus 3 over 6. 2 different answers. What's -3 plus 3 divided by 6? Still 0, right? So one of your x values is 0. The other one, negative 3 minus 6. Negative 3 minus 6, negative 3 minus 3. Negative 3 minus 3. Negative 6 divided by 6, negative 1. You got half of each answer, the x half. Just like substitution in the last unit, you take the x, plug it back into either of the originals, either one, and get the y that goes with it. In fact, we could probably do the 0 in our head. What happens, and I'll erase the substitution part. What happens when you put a 0 there and there, there and there? What happens in the first equation? What do you get? You get 0 plus 0 minus 5. You get negative 5. What do you get in the second equation? 0 minus 0 minus 5. You get negative 5 in both of them. That proves that no matter which one you plug the 0 into, you're going to get negative 5 to go with it. That's this point that I crudely drew in the picture. Negative 3, I'm sorry, 0, negative 5. Now the other point, negative 1, plug it in. It's up to you. We called this step 3, by the way, in substitution. We called it step 3. Plug in x equals negative 1. I like the second equation, I'm sorry, the first equation better than the second. So I'll plug my negative 1 into the first equation. I get 2 times 1, I get 2. Minus 1 minus 5, I get negative 4. For the sake of time in the video, if you put this in your calculator and you looked on the table, you would see it crossing at those 2 points. You'd have the same y value in the y1 and the y2. All right? So I'm going to pause the video, and I want you to try 8 and 9. 8, try it with the calculator. 9, try it with the calculator and algebraically. The difference being one of them is a line this time. So a quadratic and a line could do things like that. 2 answers, 1 answer, or no answers. And we already looked at those over here. All right, calculator's ready to graph. Here's number 8, the picture. What does it kind of look like? Does it look like it's crossing twice or once? Or kind of looks like it's once. But I'm going to zoom in. We've never done this on the calculator. Zoom in, hit zoom, go to the second option, and I'm going to zoom in, move my cursor up towards the area in question, and hit enter, and it will zoom in on that spot. And we can start to see a little bit better that it is just touching in one spot. When you go to your table, it's the point 0, 2. 0. If you did this problem algebraically, here's what would happen. Algebraically. When you did the quadratic formula, after substitution, your discriminant would be 0. And if your discriminant is 0, the square root of 0 becomes 0. You only get one number for x, and that one number would be 0 itself. All right, kind of tricky. All right, I'll pause it, try number 9 in the calculator, and substitution. All right, since we're running out of time, we really just don't have a whole lot of time to give you to try this one. Substitution-wise, you take negative x squared plus 2x plus 18 and replace y in the second equation. Now, I like a positive x squared, so I'm going to move everything to the right side of this equation. So I'm going to add x squared, I'm going to subtract 2x, and I'm going to subtract 18. And combine like terms. The left side turns into 0, and the right side now says x squared, a 5x and a negative 2x, plus 3x, and minus 28. I'm going to pull out the quadratic formula. Opposite of b, plus or minus some square root over 2 times 1. Discriminant is 1, b squared. I'll model what I did in class. I'll go ahead and not do it in my head. B squared minus 4. B squared minus 4 times A times C gives us a 121, which hopefully you know that number as a perfect square. The square root of 121 is 11. All right, so our 2 answers that we're looking for, blank, 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 One of them has an x value of -3 plus 11, 8, divided by 2. One of them has an x value of 4. The other one has an x value of -3 minus 11, -14, divided by -7. To find the y that goes with them, plug those x's back into either original. Which of those two originals looks like it's the easiest to work with? Yeah, the second one. So when you take 5 times 4, 5 times 4, 20. You subtract 10, 410. When you plug in a -7, you get 5 times -7, 5 times -7. So y equals 5 times -7 minus 10, you get y equals -35 minus 10, you get -45. Would you have seen those points in the picture of your standard 10 by 10 window? No, so you'd have had to done some digging in the table to find them, but you still could have found them. All right, so that's Learning Target 12, Part 2, Solving Equations.